Hello, everyone, and welcome back to my channel. Today, I'm starting a new series, Physics in 5 Minutes, where I explain complicated physics concepts in 5 minutes or less, or your money back. So today, we're going to be talking about gravity. So forget everything you ever heard about gravity. Now, this theory is speculative, but I think it makes a lot more sense than, say, warping space-time, okay? So here's the secret. This is what gravity is. Gravity is like when you took your balloon and you rubbed it against your head and you put it against some little paper clippings and they were attracted and they actually got stuck onto the balloon, or you could take the balloon and stick it on a wall. What is that? That is an all attractive force, okay? And the secret is that is exactly what gravity is. It's not any more complicated than that. Gravity is just an electrostatic force. So you have the Earth, and electrons are readily lost off of any large object, just like the balloon. And that creates the Earth with a fairly large net positive charge. And then we are acting on the Earth as if we were the little bits of paper. And we are stuck to that by this electric force. In fact, if you took a balloon and you put like a bug on the balloon, that bug would feel a force which is indistinguishable from gravity. I mean, the bug could jump up and they would find that they'd fall down, and they could walk across the entire circumference of the balloon and still feel attracted. And so I'm saying that this is not an analogy. It's not similar. The force that you see attracting objects to the balloon is, in fact, the same thing as gravity. Now, you're probably wondering, well, how does that work? You know, gravity is only an attractive force, and, you know, people don't think it is. So I have this little diagram here to show you how that works. So let's pretend that this is like the Earth, which is a very large positively charged object. Now, inside of all of us, the atoms and molecules are made of what are known as dipoles. Everything is made out of positive and negative charges mixed together. So we have these dipole objects. Now we know opposites attract. So the negative side will be attracted to the positive charge, and the positive charge will be repelled. So it puts the dipole in this position. It will want to turn in this direction. And because the negative charge is just ever so closer than the positive charge, this means that this positive charge has a stronger attractive force than the repelling positive. So that causes all of this to be attracted to the positive charge. And that is basically how gravity works. So what's the evidence of this crazy theory? Well, first of all, main evidence is that we are immersed in a very, very large electric field. It measures about 120 volts per meter. That means between the bottom of your feet and top of your head, typically you're sitting at least 600 volts worth of charge displacement. And anything that's in a strong electric field will be attracted to the source of that electric field. I mean, that's just physical fact. So the fact that we measure a strong electrical field basically proves that some of that force must be due to that field. And if you look around, you know, you see a lot of electrical activity in the Earth. We see thunderstorms, between the ground and the ionosphere is something like 300,000 volts worth of difference. That's a huge electric field. And also the other evidence is that there's something called a diphoelectric force, and they measure this. I mean, the force between dipoles and charged objects, that's a real physics thing. And we know that that works. And if you calculate how much force you think the 120 volt field should generate on, say, me, it turns out to be about 150 pounds, which pretty much accounts for all the gravity. So that is actually very good evidence that gravity is just electrostatic force. Now, how could you prove this? Well, you could probably try and prove this by showing that the electrostatic field does in fact have all of the same properties of gravity. If you took a sufficiently large mass, and if you looked at it carefully, and if you didn't say, this is the main mistake they make, that they ground all of these objects to the Earth, which means it gives it the same charge as Earth. But they need to look at it carefully to make sure that if you took an object and you truly made it neutrally charged, no charge at displacement at all, zero, I think you would find in those experiments that the gravity field would in fact disappear from those objects. And some practical applications. So one thing is that it'd be nice if we could defeat gravity. Now, if Earth is just a positively charged ball, then you'd think if we just come up with something that's positively charged, that would in fact repel from the Earth instead of being attracted. And so that is in fact something you could do, but the problem is that there's still mostly, it's very hard to get that kind of charge displacement. Like you'd have to charge the thing up like by millions and millions of volts before you would start to see a change, because you are still working against all of these dipoles, which are all pulling, right? So just a few little positive charges here pushing away is not going to overcome that. But if you were like Elon Musk and trying to put a spaceship into orbit, you might find that by simply charging up your spaceship to the same charge as the Earth, that you will get this repelling effect, and you may in fact be able to save significant amounts of rocket fuel getting to space. So that would be a practical application. Another practical application is that if all gravity is due to this alignment, if you could do something to mess up this alignment, like cause it to go this way, then you could also decrease the force of gravity upon you if you could screw up this alignment. So that's perhaps another way that we could defeat gravity, by using the theory that it's just the electric force. So that's all I have. Hopefully that was less than 5 minutes, and we'll see you in the next video. Ta-ta!